Before we get started, just as an important act of reconciliation and gratitude, I want to take a moment to acknowledge that the province of Alberta is comprised of Treaty 6, Treaty 7, and Treaty 8 territory, the traditional lands of First Nations and Métis people. We acknowledge the many First Nations, Métis, and Inuit who have lived in and cared for these lands for generations. So if any of you are new to SURIA, this is your first time joining us, it looks like most of you are well aware of who we are. But SSRA is a not-for-profit organization with a mission to accelerate the adoption of innovative low-carbon solutions for buildings, as a means to revolutionize the industry and reach the very important target of zero carbon buildings by 2050. We work collaboratively with industry in pursuit of this mission and provide support and growth opportunities for companies in the form of demonstration project funding, business growth services, and sharing the latest expertise on innovative low carbon building tech products and practices. So today's session is actually part of a shared learning series where we feature the valuable learnings that come out of demonstration projects that we have funded. So we actually have currently 9 demonstration projects that have been funded or receiving funding. And the approvals on those occurred as far back as a year ago, all the way to about 6 months ago or so. And we have another group that have recently been approved and that we're actually just working on finalizing those agreements so that we can announce those projects as well. So all these projects are going to have some incredible data and learnings coming out of them, and in pursuit of that mission to really move and transition the way industry designs, engineers, construction, even maintains their buildings. We want to get the word out ultimately and share that data. So one of the ways that we're going to be doing that is through these shared learning webinar sessions. So really happy to have you join us today. So today's presentation is on the Concordia University of Edmonton New Academic Building Project. This project is led by Reimagine Architects, and they are going to be applying an innovative approach to improve the performance of the building envelope. The project is still really in early stages, so Vacuum can share a little bit about what the planning and some of the analysis that took place in order to develop kind of the envelope that they've decided on. And of course, down the road, we'll get to see how that all results in actual energy reductions and savings, and all the other great benefits that we would expect out of kind of a high-performing building. So for those of you who don't already know our speaker, Vedran Skopak, he is a principal at Reimagine Architects and an internationally recognized architectural designer known for creative design and execution of projects with a regional impact. So we'll hear from Vedran, and then we will open it up to questions. And as I mentioned, the recording will be available to those registered participants. So with that, Vedran, do you want to take it away?
Yeah, thank you, Pam. So I think I can, there's some direct chat messages. I think I can share screen now. Let's see if this will work. Can you all see my screen now? Can you all hear me? Yeah, okay, I see some nodding, and seems like most of the folks on the call are already quite familiar with what SRIA is, and a few that I don't know, and I will make some strong assumptions that most of people, great majority, already know what SRIA is about. I'll still go a little bit into that, but so please ask more questions. You can raise your hand, and then we can stop and then talk about whatever you think needs more clarity, or we can leave it all at the end. So I'll just go quickly through the few presentation slides of what we're trying to achieve here, and what this project is about, and then we'll skip into questions and answers. Does that make sense, Pam and everybody? Yeah? Okay, so this is a project that we call Concordia University of Edmonton, new academic building, and it's a building that it's on their site, their downtown Edmonton site, right near, if you're familiar with Edmonton, this is how, I'm assuming you can see my cursor. This is how you would enter the Concordia campus, and then it would be right here on your right side. And your most familiar entries to Concordia are probably here in the whole academic center and alumni hall and so on. So what we are working on is this NAB, or new academic building, which will be connected with this bridge to another building, which is called Quad or Quadrangle, so doing Quadrangle. And we are designing NAB. Quad is designed by Neifeld Architect, who is also a prime consultant on for the overall project. And we are working on the site and also with the neighbors on engagements and on the rezoning of all of the site. This is how the site looks like, and pretty much the scope of work. The building will be full of classrooms and fun places for students to gather, and bridges and stairs everywhere, two larger halls tucked in the middle that create some interesting sectional opportunities, as well as two-story underground parkade with about 120 car stalls. And the building is, as you can see, split level from 2 stories to 3 stories, about 12 meters tall. And it's altogether just over 100,000 square feet. Out of that, 60% would be above ground and 40% below ground, and another elevation and section showing the experience of the building from, as you would see it, walking from the main campus to the building. So when we first heard about SRIA, we were very excited about what this opportunity might be for the project and for the university. And we knew that this might have come for one of the first projects to secure that round of funding, and it would be a great story to help position Concordia University of Edmonton. We should always, by the way, have to be careful that Concordia University is another university also in Montreal. So this one is Concordia University of Edmonton. So CUE for short. So they really want to position themselves as the leader of sustainable design in the community, and this is an important project for them. So SRIA stands for Smart, Sustainable, Resilient Infrastructure, and it's a non-for-profit, publicly funded initiative to support innovations with the goal of reducing greenhouse gas emissions and carbon, lowering carbon in general, as well as the embodied carbon. So thinking about that, we needed to have a clear idea why to even apply. We need to make sure that what we are applying is aligned with Concordia's values. We understood that this will be incremental funding to improve the budget that we already have to create this innovation. We knew that this would be a great story, and that it would create a lot of collaborations. It would support local businesses, and it would provide also educational opportunities for Concordia to actually implement into their curriculum. And as such, we wanted to focus on the weakest component of the envelope, which is always the openings or glazing. I won't bother you with a lot of details, but just to give you the close note of some of the options that we were looking at. So the first option we looked at was the high-performing curtain wall with integrated photovoltaic cells in addition to vacuum glass. We were excited about looking at the product that we are very familiar with, that we helped launch in the market called GlasCurtain curtain wall, which is a fiberglass-based curtain wall, which actually achieved the Passive House standard, and is one of the best performing products in the whole world. At the same time, we got very excited about this new product on the market, which is the Vacuum Insulated Glass Unit, or VIG. And we were wondering what would it take to actually start adopting the curtain wall systems to this new package that has a little different requirements, which are dimensional and other. Knowing how much better the vacuum glass units would perform, the biggest question was, could we get it in time? Will the client have sufficient support in maintenance? And will the price be competitive? So practically support and time, and how much would that product actually create savings or reduce our greenhouse gas emissions, as well as not to forget how much the actual fiberglass curtain wall reduce the embodied carbon expense on this project, simply because we're not using metal, such as the standard aluminum curtain wall, for example. So we based our performance of our curtain wall to the baseline, and for that we used two different standards. One is the basic NECB prescriptive method performance of the curtain wall, meaning if we were not to have funding, what could we get away with? Meaning there's the same story. There's not enough money. There's no budgets to do something innovative, and this is not the battle we want to fight now. So let's make sure the client invests the minimum in the glazing, for example. And for that, you actually could get away with something like USI standard values. So the resistance properties factor of the assembly of 1.9, just for the order of magnitude. What we are achieving with this product is 0.63, including the thermal bridging. So that's the overall effective performance. And that it's also quite substantially better than the best. Our second reference was the comparison with the what would it be? How well would the best aluminum curtain wall system perform on the market? And that one dropped us to 0.95 USI value. So we go from something that it's a minimum required by code in a energy code prescriptive method, which would be 1.9, to what's the best metal composition of curtain wall system plus the glazing unit, which would be 0.95, to what we are doing with the fiberglass and the vacuum insulated glass, which would be 0.63. So in this journey, we have partners. Our partners at Concordia, University of Edmonton, as an owner and the educator in this process. We're working with Revolve Engineering energy modeling on energy modeling and optimizing the assembly. GlasCurtain is the supplier of fiberglass curtain wall system, and they're also outsourcing they're also working with the glazing trade to outsource the vacuum insulated glass, but they have to make design modifications and their system modifications to accept the new package, and build sense that will actually provide measurement and verification in the use of the building. So we plan to finish the building by Christmas of next year, which means we would have. We were hoping that we will have about 6 months. It looks like we will have just over 3 to 4 months of a measurement and verification period before that sacred date of when Sriya has a milestone and gets a renewal likely on March 31st of 2023. So we are basically promising measurement till March 31st of 2023, hoping that that will get extended so that we will actually have opportunity to do the 5-year full measurement and see how this envelope actually in reality performs in comparison with the rest of the building. And our company, for the ones who didn't know that, is renamed from Manasc Isaac Architects to Reimagine Architects, and we are in a role of a facilitator and a designer of this project. So for the envelope innovation, this is how the standard detail for the fiberglass curtain wall system would look like with the standard triple glazed unit. And here, what is important to note is that I'm assuming you can see my cursor. At this line here, you can see that there's some sort of combination. The detail has this lock-in profile, which also means that there's a transition between two materials. This is where the fiberglass transitions to metal. This piece is actually metal, meaning that this is the piece that we don't want to push too far back to the back of the glass, because this is what is considered conventionally to be our vapor barrier line at the back of the glass. And the dew point is somewhere in the this package, this glass unit. So we want this package to be as further out as it can, but not to have any metals protruding in, because in a not very well performance of the curtain wall. So most of the metal curtain walls, because of this metal transition here and thermal bridging, this is where most of the thermal bridging happens through this nose. This line actually in a metal curtain wall, these blue colors actually go deeper in all the way to the back of the tube, which is why when in our climate, for the ones who may not be from Edmonton, we do get even -40 temperatures. We do fall into the winter vortex of -20 for over 2 weeks. Metal curtain walls actually are quite cold and not very pleasant to use in our buildings. And that cold also radiates into the space, and it's not pleasant to be even near it. So there's a direct impact on the usable square footage in the proximity of metal curtain walls. In the fiberglass curtain walls, the back of the tube is, as you can see here, red. It means that it's it's still in the warmer temperatures, and it's very pleasant to actually touch the fiberglass curtain wall even on -40 temperatures. And the vacuum insulated glass units that we are now looking to put into, combined with the fiberglass, is comprised out of two elements. One is this two-pane sheet with a vacuum portion, meaning that the air is sucked from this space so much that it receives the vacuum grade. There's a very little air pressure here, and very little molecules that could carry the thermal energy across. And they're spaced out for about 0.2 millimeters with silicone spacers. And on the edge, the unit is sealed with non-metal products, another type of silicones and glues that actually keep the unit together. And manufacturers are giving us warranties that are higher than what we will see on triple glaze units on the market. And you could consider this to be a triple glazed. However, this package is the vacuum package, and then there's another portion with argon gas and another pane, which also is insulated. So some manufacturers are recommending to put the vacuum part on the outside, some on the inside. It does make a little bit of a difference in the way we calculate it and the way it's performing. However, not that much, and we are open to both solutions. And what we're happy to see is that since we started this project, what we're receiving as a result, test results for the performance of this product, as well as how price is becoming competitive. It's a bit of like a PV market. It's quite dynamic, and it's going. It's very optimistic. It's progressing into our favor, meaning that when we started, we only have one, maybe two, 1.5 kind of reliable suppliers, and one was Canadian, the other from Korea. Now we have 6, and we are happy to see that Viracon, which is a giant from US glass supplier, is reliably supplying vacuum insulated glass, shipping and supporting the product throughout the continent. So that gives us confidence that this will actually go well, and that it will be successful in installing. And the first scenario that I mentioned, which was to push this even further and to see whether one of these panes can actually be 2 panes laminated, so that we have a sort of like a 4-pane package, to give us the opportunity to laminate photovoltaic cells, like you see on this image. Similarly to what the familiar example to people from Edmonton might be is the Shaw Conference Center did their renovation of their glass roof, and they didn't cover it. It was smart not to cover it with opaque panels. So this place still somewhat functions as a sort of a greenhouse with this beautiful light and air. However, the light now gets filtered through this veil of photovoltaic cells that are laminated inside. This was a little too much to be able to guarantee all the warranties and all the support and all the costs, to justify the cost. And mainly, it failed on the quantities and cost, because for the funding that we have available, the area that we will be able to do in PV laminated glass would just simply not justify the energy savings. So when we put together the carbon savings versus the investment, it just didn't make sense, especially because the photovoltaic system involves some wiring, and it involves inverters, and involves electrical engineering to do some more work. So we skipped that part and focused on what sort of our base 2 comparison would be, which is between what we consider the one of the best performing aluminum products on the market. In this case, aluminum ThermoWall 2600, which, by the way, we are using in all the areas in the building that we are not able to use fiberglass Sria innovative curtain wall, and then we'll also not only that we are making calculations in comparison, we are in monitoring. What BuildSense will do is they will place a bunch of sensors on both curtain walls to measure the performance of both and provide data and reports of what that would mean. So we are now in construction of the building. The tender was completed in early June, and we started construction in early August of this year. So it's pretty new. We're in excavation and shoring work now. Prior to that, we have obviously a design phase with 2 milestones. One was in more schematic phase, and the other in construction documents phase. And then the 4th milestone would be the post-construction phase, which will include the monitoring and reporting back. In terms of what the amount of funding is and the distribution of funds throughout 4 milestones, the milestone that we are now in receives the highest amount, because the highest cost is in material and labor in construction, and the total is a little over $460,000 with some substantial in-kind contributions because we understand that we want to invest a lot of our team time on this, because we want this project to succeed. And graciously, all of our team members agreed to do so as well. And there's a part that we didn't know how it will go, how quickly we will figure out things in achieving this what we feel it's innovation, and some of the details of what each milestone entails, of what some of the activities and deliverables. Basically, in this phase, we will be reviewing shop drawings, and we will be constructing the curtain wall on site. And what is newer to our process is how the actual funding will flow. We had to explain this to ourselves first, and then to client and to the contractors, and how the actual how to actually position this bidding and write it up in our tendering. And for me personally, one of the biggest lessons learned is actually there in a specification related to the funding. I don't know that we would do it the same way, simply because when we ask for alternative price, or we say this is the base, and provide us with the additional cost for this improvement, a lot of contractors assume that this is something that will actually not happen or may not happen, and they put a little higher premiums that we would like on this part, which then directly jeopardizes the quantities that we can use, because the funding is sealed, limited, it cannot be changed. So and the performance is what it is, the market prices are what they are. So, and then because of that, we were expecting that we will negotiate the quantities a little bit. Luckily, we didn't have to reduce much, and we are proceeding as planned, and it will be built by the fall of next year. So I'll stop right there. There's plenty of more details and informations, then we could drill into numbers and reports. There's an extensive reporting that also Kishwar Habib, who is with Reimagine now, and she's a postdoctoral fellow researcher. She helped us do research on both vacuum insulated glass, as well as how much would that new product be birth friendly, and other reporting that we provided to Sria. But I would really like to hear if there are any questions from group, and be more sort of like create this more of a dialogue than me just rambling around. So thank you very much for listening.
Thanks for that, Vedran. That was a really great overview. And maybe just since you kind of touched on the research that Kishwar had done on the VIG, which was a really great detailed document. And one of these great things that we get to, with the funding that we now get out of this project, and we get to share with the members and the stakeholders. So that document is available on our website. Kat, you may have to remind me exactly where on our website, but there is a project section on the website, and we're in the process right now of actually working out how all this information will start to be displayed as we start to receive more and more details. But if you want to dive into learning a lot more about VIG and the various different suppliers, that is a really great document to take a look at. Maybe while folks think about their own questions, I actually had a few that I had lined up as you were speaking. I'm just wondering, Vedran, if you can, share what some of the key data you think that will come out of this project that will really help to increase, I guess, the market uptake or the implementation of both the fiberglass curtain wall and VIG in future buildings.
it's better, works better when you unmute yourself first. Yeah, for sure. The fiberglass, GlasCurtain fiberglass product is no longer an innovation on our market because it's now used in various cities in different climates further north in the Arctic, and there are 6 installers that are licensed to install it only in Edmonton area. So even in Alberta is now a substantial amount of installers and support to install fiberglass curtain wall. However, we are excited about this, how the vacuum insulated glass will work with a product like fiberglass, because it didn't really make much sense for us to put it in a metal curtain wall. We would consider perhaps maybe a wooden curtain wall, but not metal, because the thermal bridging is a substantial concern in performance of our envelopes. And now luckily is the energy code requirement to actually calculate the amounts of thermal bridging. And you wouldn't believe how much it deteriorates the performance. There's a lot of perimeter, a lot of connection details in every curtain walls, which is where the weakest points are. So the framing, we feel that, luckily we feel like framing we already figured it out. However, we were excited about this glass that has, for order of magnitude understanding, R16 center of glass unit performance, which is substantially higher than the 2.2 what we would see on the market, or what we would typically use would be around 6.5 on our triple glazed unit. So now this exceeds that by 2.5 times just on the glass performance. We're hoping that the lessons learned from all of this will be that we will remove any concern with using VIG units on our market, that they will become something that it's ubiquitous, and that owners and operators will have confidence in using, contractors in installing, and specifiers and cost estimators to actually including in the project and supporting those ideas. The support and the repairs is a whole other kind of worms that we need to open when we are talking about this, because those are the first questions that we have, and we're looking forward to have this project as a success story, because for both that part, supply and maintenance of the actual product, and for the results of the monitoring that we quite often don't get to do, because there's never enough budget for that, as you know. And what SRIA is helping us do is to precisely that, to secure funds for monitoring and reporting back. This is what is telling us how we know that energy modeling is not perfect, and this is telling us exactly how much.
So if anyone else has questions, feel free to just unmute yourself, or you can also use the chat box and just type your question in, and I'll watch for that as well. But maybe I'll just give a moment to see if anyone wants to unmute themselves and ask any questions right now.
Hi, Vedran, it's Trevor Butler here.
Okay.
Hi, I think it's great to see this product being used in Edmonton and with your firm. And so on a practical side, like when we've talked to other clients about using these panels, they've been concerned about kind of protection and physical protection. I just wonder what measures you've sort of learned in how you're using these on site and in the life cycle of the building to sort of maintain their integrity and keep them well protected. Is there any kind of lessons learned that you could share on how we can help to assure owners that they're a good product fit for service and that kind of thing?
Yeah, thank you, Trevor, for that question. We actually did have this conversation with the client. One of the concerns was, a pane that gets broken. So what happens there? Do we, tape it temporarily and board it? And will anyone cut themselves? How quickly can we ship a new pane and reinstall this? Is that going to become a problem? Regardless of whether the pane is the vacuum portion is from the inside or the outside, because it actually the glazing trade has to take sort of like two different pieces. One is this vacuum insulated portion, and then start building from that which gets manufactured separately, and then create a triple glazed package of that. What we've seen from our research is that that insulated portion, if it's from the inside, it's even stronger and more resilient to the impact. And in terms of the manufacturing time of replacement for a unit and shipping on site, there's no difference than any triple glaze. There's no time difference. There's no difference in what would in life safety, as that. Now that whether it's from this or any other glass, this is a safer and better package than what we see in most of the residential skyscrapers, where not always triple glazed units are used, and the framing system is not as robust as this. So and you are standing up there on a much higher altitudes. In this case, there is a substantial portion that is on the ground level, and the building is relatively short, not very tall, and so the zoom boom can access most of the building from the site. We've done that analysis, and even with the if we end up with a unit where the vacuum portion is on the outside and the inner pane breaks from the user behavior or whatever accident, it doesn't matter. The outer portion that it's vacuum insulated is actually providing this bigger bulk of the thermal resistance, which means that during the time, in the time of the repair, that glass unit will still substantially perform and not cause condensation and freezing in the system. And for all these reasons, we actually think that this is the future of the glass, that we need to seriously consider this and start building it more and more, especially because the performance is whole other discussion about how important it is to improve the weakest component of our envelope, which is the openings. And we can't just say, let's not have windows in our buildings. We need to have windows, large windows. They're good. Openings are great. However, how we do them, I think this is something that has to dramatically change of how we see the performance of our openings to achieve our goals for Architecture 2030 and also being net zero by 2050.
Yeah, thanks for that. And a quick follow-up. In the middle of winter, do you think from a temperature perspective, we would still need to have perimeter heating in front of one of these panels? Or do you think the performance is going to be to the point where, you mentioned like a high-rise residential tower, maybe in the middle of winter with that kind of high exposure, do you think with this kind of R values that we can get away with perimeter heating, or are we still going to need some of that?
Mm-hmm. That's a very good question. So just to frame this response, we have a long track of designing high performance envelopes, some of which are with fiberglass curtain walls and triple glazed units, in which case, based on our calculations, we would assume that the building can go without heating for over 4 days without having any substantial, any failure. And we do have examples. We were in the year after the first operation of Mosaic Center down at the South Edmonton, a client would would call me and say, and send me photos. Look, it's minus 10 outside. The heating is not on, and the atrium windows are open. They're automatically open because of the greenhouse stack effect that happens there and how building performs and this envelope performs. To fully respond to your question, Trevor, it really depends on the mechanical system and the designs that were and the design decisions that were made there. In the building like this and with institutional clients, what we usually find is the operation and maintenance of the mechanical system is usually the one that governs. If we were to design this building to be fully net zero, we would have taken a completely different approach. It would be fully electric building. In this case, the heating system is mainly airborne through VAV boxes, which is quite efficient, but it's still natural gas based, and we like that system. However, the premise of that operation was that the system, to save the cost, will be completely shut down when the building is not in use. Meaning, it is very much expected that most of the day, most of the time, especially in the night when it's colder, and there's no body heat, there's no other redundant noise in the building, the building will actually not have heating on. And for that reason, a perimeter hydronic loop was installed just to keep the building temperate and to make sure that there will be no freezing there. And there will be periods, as we know, that students are not in the building, and there's more than one day that the building is actually not occupied. There's more than a week or even a month that the building will not receive. And in times of COVID, who knows how much the building will actually not be occupied. However, the size of the perimeter radiant panel shrank from 2 feet wide to 1 foot wide in the areas of SRIA innovative curtain wall areas. So we did see a little bit of reduction in mechanical system sizing.
That's great.
Thanks, Vedran. I do have another question here in the chat. So do you know what the overall U value was of the curtain wall itself? And how is that compared to the typical metal frame, triple pane curtain wall? Mm-hmm. And then again, same question on the cost. Like, what is the difference in the cost between this assembly versus kind of that typical triple pane aluminum curtain wall?
Yeah, for sure. No, that's a great question. Like before we even started with more enhanced, more sophisticated energy modeling, we always do our analytical version, our whiteboard hand sketch version of energy modeling, and basically what we came up with the overall performance is, can you see this spreadsheet? This is what we came up with basically of, this summarizes the performance, what we briefly chatted about. I think it's always important to frame the question and response in what does it relates to. And our base model, in this case, I'll repeat, was we have two base models. One base model was what we consider the absolute minimum that need to be built to meet the codes, which is in description, aluminum framing and triple glazed units, for example. There are other ways to achieve this, 1.9. And then there's an intermediate base model, meaning, well, if anyone ever raises the question, well, why didn't you like improve the metal curtain wall? And do you have an idea how good would that perform? And when we did that in the past, we completed a college in High Prairie that actually has a metal framing with triple glazed units, which performs 0.95 USI value. For this application and this system, we calculated with thermal bridging that the effective performance would be 1.1. And what our what our calculation for the effective performance of the, say R16 glass plus the fiberglass curtain wall would be with the thermal bridging is 0.63. Now the real value of this comes when you're looking at U values rather than R values, because we feel that it's quite deceiving when we talk to our clients and say, well, we can improve the glazing from R6 to R9, and they're like, yeah, well, that doesn't seem much. Why don't we improve opaque envelope, solid part of the wall for the same? But when you inverse the question and do the inverse calculation, which is the thermal resistance, the U values, then the differential becomes much greater, and it's simply math based. And this is how we can argue that the improving the weakest component is actually helping balance the energy performance of our buildings, and it makes much more sense to improve the glazing than to put more money, more investment into opaque portion of the curtain wall. To us, 0.63 effective performance is effective, very effective and efficient performance. It's the best that we could ever hope for on the market.
And then what about on the cost question? And I know you said at the beginning of the presentation that you're already seeing costs on the VIG specifically starting to come down. Yeah. But how does that compare?
Yeah, so for this is our working. So this is, by the way, what I'm showing you. It's all the live materials that our team is using, that we are using to do our rough and more detailed calculations before we go. Revolve Engineering goes and do their own more enhanced energy modelings. We're doing a quick checks and to make sure that we understand of how much approximately area we can afford and to still be within the funding. And for that, we had to have, for example, GlasCurtain being part of our team, for them to do the research on the vacuum insulated glass market, the cost of it, and provide the overall cost of what they think in tender the upset amount of this innovation will be. That amount is incremental 850 to the curtain wall base cost of 1,000. So the base curtain wall that we are using is Alumicore Thermowall aluminum system with triple glazed units, which came into tender $1,000 per square meter. The innovation part, in order to ramp up the performance from 1.9 to 0.63, the incremental cost is $850 of incremental to the 1,000, and the area that we could achieve is quite substantial because it's 30% of the overall envelope system, of the overall glazed envelope area. Does that answer your question?
I believe so. I think that's a pretty clear, pretty clearly shows the incremental cost and differentiation. And I think that's something that we see in all our projects, and one of the ways and reasons we evaluate our projects when we're considering project proposals is kind of that commercial viability of a product once it goes through a demonstration and proves that it has the ability to reduce the GHG emissions and energy use of a building. Will it actually have commercial viability to continue to be replicated in other projects? And we definitely accept that there are additional costs involved when you're a leader and taking, starting to use a product, or one of the first to start using products And I think it's really great to hear and to see that the costs on this product is already coming down to start to open up that opportunity to, really accelerate the adoption of this particular product, as it shows some good kind of energy and GHG reduction potential. Is there any other questions? We have just a few minutes left. Any final questions from anyone else?
Hey, Pam, I had a couple of questions for Veteran. Veteran, thanks for the talk. A couple quick ones. In terms of any glazing system, it's always about the seal, and the ASTM spec. Also, is the assembly, is it stick build? Is it unitized? And what would be the floor limitation in terms of how high we could go? Thanks.
Oh, thanks, Kamal. All great questions. I can tell you've been around. You know what the concerns are out there in the market, and seals are probably the biggest discussion we had in terms of what is the potential failure of this system, other than other maintenance concerns. The seals. We don't know until we use it for 10 years. That's the short answer. However, what we I hope you can see the spreadsheet with the 4 manufacturers that we looked at. This is how much of warranty they provide, and it's more than what they provide on a triple glazed units, and it's a new product. So this gives us the biggest confidence is when the suppliers are saying, well, we believe in this. We believe that this seal won't fail. This vacuum will not get out and become and void the trigger the warranty. And if it does, we have the warranty. So and simply the way the package is built, this vacuum package is built, that they're not using metal. The 2 sheets are substantially more closer than, the gap. You can see here in this, the makeup line, what the difference of the gap is. In this, this stands for like the 5 millimeter pane, and then VIG, the vacuum portion, then 5 millimeter pane, then 18 millimeter gap filled with argon, and then 6 mil flow glass. So we're comparing 0.2 millimeter here in the VIG versus 18 millimeter or 16 millimeter in the argon portion, which is typically spaced out with only on perimeter with metal spacers, aluminum spacers, and a bunch of silicone and other products, which will simply physically has higher chances of failure than the vacuum portion. So we actually don't have any reasons to suspect that this will fail any faster than any triple glazed.
If they're able, if the manufacturers are willing to warranty this thing, kudos to them. I'm all in favor. When you have a new technology, it's new. You don't have installs for 20 years old, right? So I hope it works. It would be fantastic if it does.
Mm-hmm.
The other questions, is it a stick build? Is it storefront? Is it unitized?
Oh, yeah, sorry. The second part of your question. Sorry, Kamal. Thank you for a reminder. Yes, it's absolutely a stick build. Most of the curtain walls that we built are stick built. In both fiberglass. GlasCurtain doesn't have a unitized version, and aluminum curtain walls that are unitized are typically we find pricier. However, there are products out there that are unitized that we liked their seals, and we're actually working parallel to this. We're working on another innovation that it may or may not ever get applied for SRIA, which is the unitized aluminum curtain wall detail combined with the mass timber unitized framing for curtain walls and VIG units. So we're trying to do all in this other world of curtain walls, the unitized world of curtain walls, that we know is able to to be built in a different way on different heights, and typically loved for high-performing towers. We did a competition for Vancouver, where there's, in addition to everything, to all of what it said, there's a higher seismic requirement and the differential movement of the units. So both are true. Stick built frame and unitized, both can be built in higher altitude, so the higher floors. We never had issue with that. We did up to 6 stories in wooden construction. The residence in Red Deer College is mass timber, which means that there's more sagging and more movement of the structure, and it's built with fiberglass curtain wall, 5 stories tall.
And last one, the third part. How many floors can we go?
I've actually never heard of limitations for that, but I can ask GlasCurtain to provide if they have any limitations. I don't think that there is necessarily. It's about more about the support of the verticals and continuing the vertical the assembly up. I don't think that there are limitations in height. Can you clarify the question? What do you think?
In the past, there's been issues when you get to a certain height in terms of non-combustible materials and the distance between the opaque areas and the visible areas. And again, you know, municipal guidelines, provincial guidelines are all over the map. So I was just curious, because building a 1 or 2 story is much different than building above a 6th floor and then 10 to 20, right? So, you know, they'll probably know, but I mean, I love this stuff. You know, we need to dramatically improve the performance. So when you see this stuff, you just hope it works and it's going to be good for everyone. So
I'm sorry, I don't have the full answer for you today about the height of the glass curtain, fiberglass curtain wall. Height. I'll make sure I follow up on that with you. However, GlasCurtain did receive the fire testing, so it's fully licensed system, non-combustible, and there's additional funding for additional testings being secured just recently through Alberta Innovates. There's been additional round of fundings secured for additional testing. So I think the future is optimistic on how high this system can fly, and I think the sky is the limit, literally.
Awesome. Thank you so much. Appreciate it.
Thank you, Kamal.
Yeah, the GlasCurtain story is a great made in Alberta innovation and solution, and so we're really happy to have them included in this project and kind of putting it together in a different way for this envelope. So thanks so much. We've hit our 1 o'clock point here. Great conversation, great information, Vedran. We really look forward to seeing the data and the results that come out of this project and kind of watching it as it's built. For those who are interested in kind of future event updates, I do encourage you to sign up for a newsletter. If you just go to our webpage, scroll down to the bottom, there's a newsletter sign up there. We have a virtual coffee event coming up September 30th. This is a really informal event where we get to kind of sit around and have these maybe deeper discussions around a specific topic. So the one we're going to be discussing on September 30th is kind of how to start a residential retrofit revolution. So just a great way to network a little bit and get those creative juices flowing. And we're just finalizing our event technical session we have planned for October with one of our members, Intuitive. So we'll have those details out shortly as well. So some more great information coming your way. Thanks again for joining us, and we look forward to seeing you at future events.